This is the example problem we did in class. Here is a cycle with 4 devices, actually 6 devices and 7 states. All of the enthalpies and phases are provided for you for all 7 states. We're interested in determining the mass flow rate for across each one of the device. We are interested in applying the first law through each and every single one of these devices, as each one is a steady state, steady flow devices. We are interested in finding out what is the cycle's thermal efficiency and determining what is the Carnot efficiency. So this portion of the video is just a quick recap of what we did in class. First question asks for the mass flow rate through each device in terms of the variable y. I'm simply just going to put the given on the diagram. We know that the mass flow rate at state 5 is 1, and the mass flow rate at state 6 is y. Since the turbine has a single input and 2 outputs, we know for steady state, steady flow devices, the summation of all masses in must equal to all of the masses out. 7 must be 1 minus y. Condenser has a single in, single out, 1 minus y. Same with a pump, 1 minus y. We hit the open feed water heater, which has 2 in and single out. The 2 in mass flow rates at 2 and 6 must be added together. Therefore, for state 3, we have mass flow rate at 1. Thus, single in, single out for pump 2, mass flow rate of 1. We then finish everything here. I'm just going to put what we found from the diagram to the table. Number 3 is 1, number 4 is 1, and number 7 is 1 minus 1. And then I'm just going to erase these. Okay? We're now ready to perform part 2, turbine. This is the first law for turbine. Talked about it in class, is equal to W dot oops, it should be a minus. Exit minus inlet plus change of kinetic energy. We neglected potential energy. In this particular case, we're going to assume that since velocity is not given, the change of kinetic energy is 0. We're going to assume that the turbine is adiabatic. So the governing equation we have left is W is equal to dot. Since the flow should be the same across the turbine, so we're going to say for stage Q dot is equal to W dot, and we're talking about from 5 to 6, plus M dot coming out 6. Sorry, we say Q is equal to 0, right? So 0, H5. Rewrite. Swapping H and 6. If I go ahead and pop in the mass flow rate between 5 and 6, this is the confusing portion because 5 comes in as total as 1 and 6 goes out as y. We're just going to be using y, assuming that only a portion of the 5 goes through 6. Easier yet, if I look at the intensive property, that's E, that's going to be like that. and you can plug in the numbers yourselves. So I'm gonna leave you to punch in the calculator. Oops. It's gonna be 3583.1 minus 2860.2. We can do the same thing for stage 2, and I'm not going to repeat the derivation of the equation, so that is simply going to equal to minus 5. Oops. H7 minus H5. And H7 minus H5, well, actually, it's going to be H5 minus H7, sorry. Because this is going to be similar to what we did. 3583.1 minus 21.3. Okay? So this is it for the turbine.